Hello, fifth graders. This is Eureka Math, and we are now on Module 6. Yay, the last module of the school year. I know you're excited. June is right around the corner. So for Lesson 1 today, we're going to construct a coordinate system on a line, which means we're going to be working with some lines, and we're going to plot them. Ooh, what's going on with my computer this morning? Hang on. I hit the wrong button, and I do not want voice options. There we go. Okay, so remember how to make lines, just like we've been working with our rulers. If this is 0 and this is 1, right, we're going to have to find out what these hashes in the middle mean. And this interval here would be 1/4, 1/2, 3/4, okay? So we already have these skills. I know you guys can do it. So let's tackle the learn pages today. So write your name on your paper, please. I think I'd like to use this teal color today. And let's start with number 1. Okay, so here we've got a number line. And it's not straight up and down, and it's at a weird angle, and it's got a bunch of shapes on it, okay? So this is 0, and 0 is always our origin, okay? Right there, that's our origin. And then we've got a whole bunch of intervals. So from here to here is 1, here to here is 2, 3, 4, 5, okay? That means that these inside, if there's 1, 2 lines inside, that means that each interval from 0 to 1 has been cut into thirds. Do you see that? 1, 2, 3, which means that this is 1/3 and this is 2/3, okay? So this here would be 3/3, and then this would be 4/3 and 5/3 and 6/3, and you get the idea, okay? So now that we've established where the origin is, where the 0 is, okay, because how they've got it on this assignment, it could be on the left, it could be on the right, it could be on the top, on the bottom. We're going to look for the lowest number, the 0, and that's our origin, and then figure out what all of those little intervals represent. And now we know that these are in thirds. So each shape was placed at a point on the number line, S. They're calling that S, or that symbol, right? Okay. Give the coordinate of each point below. And it's just a math symbol, and it's just saying that this line, that's the name of it, okay? Give the coordinate of each point below. So this plus sign, or this X, well, that one was easy to find. It was right there. It was on 3, okay? B, star. Look, I already put that number in there for you, right there. So that's 2/3. The circle is right here, okay. So what is that point? If this is 2, 2 and 1/3, or we could call that 7/3. But I like mixed numbers, so I'm going to call that 2 and 1/3. And then here we've got the square, so 4 and 1/3 and 4 and 2/3, also known as 14/3, right? So 4 and 2/3. If you were to put 14/3, I would mark it as correct. And if you were to put 7/3 here, I would also mark that as correct. Okay. All right, so actually pretty easy, right? This is not complicated. All right, let's go on. Number 2, plot the points on the number line. So here's our origin, right? And if this is 0 and this is 3, we know that these big lines are intervals of 3. So that would make this 6, okay? And each one inside, well, 0, 1, 2, 3. Okay, I hope you can see that right away. If you're struggling figuring out what those inside lines are, let me know. I know when we were working on some of our measurements with our rulers, some of you were struggling on the lines. Okay, so plot the points in the number lines. Plot A so that its distance from the origin is 2. Remember I said this is the origin, okay? Wherever 0 is, that's the origin. Origin means beginning, and 0 is always the beginning when we're talking about number lines. So plot A so that its distance from the origin is 2. So we're going to put that right here and label it A, okay? There it is. All right, this one is at a weird angle, but that's okay. It's still a number line. It still starts, there's still a 0 there, so there's our origin. Okay. And if this is a half, and this is 3 halves, this must be 1 here. And this is 2. And that would be, what, 5 halves? And then this would be 3. Now you don't have to write in all those numbers, but it sure does help me. So if you want to write them in, go ahead. Plot R so that its distance from the origin is 5 halves. See, now because I already wrote those in, all I have to do is find the 5 halves right there. I'm turning my head sideways because it's at an angle. I suppose I don't need to. And I'm going to put the letter R right there. Okay, plot R, plot A. How are we doing? This is not difficult. This is not difficult. Okay, here's C. Now this is a little bit trickier because there's no 0. And we have to figure out what each of these is. So 50 to 35, if this big line and this big line are 15, right? 50 minus 35 is 15. That means that this one would be 15 minus than that, less than that. So that would be 20. That means this is 20. Okay. And we don't know where the origin is, but we know that this arrow is pointing us there, and eventually it would get us to 0. Okay, ooh, there's my morning alarm. I woke up a little early today. Okay, so plot L so that its distance from the origin is 20. Well, I drew in the origin right there. And the distance from the origin, 20, well, here's 20 right there. 0 to 20, that's a distance of 20. So I'm going to plot my line and plot L right there. Okay. How about this one? There's no 0 here, but I know that if this is 5 and that's 4, that the origin is going to be way down here somewhere. Okay. We don't need to know exactly where it is. We just know that it's in this direction. Plot a point T so that its distance from the origin is 2/3 more than that of S. So here's S. And we want it to be 2/3 more. So let's figure out if this is 4 and this is 5 and this is 4 1/3. This would be 4 2/3. Are you with me? Okay. And this would be 4 3/3 or 5. What does that make these in the middle then? Well, if we have 4 and 5 here, and this is our single digit interval, and there's 1, 2, 3, 4, 5, 6 slices in the middle. They've cut it into 6. Then this must be 1/6. And this would be 2/6, 4 and 1/6, 4 1/3. This would be 4 1/2 because it's halfway, right? And I know it's halfway. Let me show you the change here. So if this goes 1, and this is 1, and then this is 1, and then this is 1, then this is halfway, and that's halfway. Okay, so 4 1/2. And then because each line is 1/6, so that's 4 2/3, and then this would be 4 5/6. Okay. Now that seemed like a lot of work to get all those in there, but it's going to help us plot a point T so that its distance from the origin is 2/3 more than that of S. So 4 1/6 is where S is, plus 2/3. thirds, right? More than that of S. So this is S, 4 and 1/6. So this would be S plus 2/3 equals T. So let's find out if each of these is 1/3. So 4 and 1/6 plus 1/3 plus 1/3 equals 4 1/2, right? And I did that on a number line, but I can do it mathematically as well. Okay, so I just need to make sure that this is in sixths, right? So I'm going to multiply that by 2 and this by 2. And now I have 4, wait a minute, did I do that incorrectly? 2/3. I did. Look at that. Sorry about that, guys. Here, let me be more careful. 2/3, and each of these is a sixth, right? So sixth would be 4/6, right? So here we go. 1, 2, 3, 4. Sorry. 4/6, right? If 2/3 equals 4/6, I'm going to have to count 4 intervals between S and T. So T is going to go right here. Okay, right there. And 1, 2, 3, 4, good. And that's 4 and 5/6. Sorry. Hope you caught that mistake before I did. 4 and 5/6. Okay. All right, and there's T. I'm glad I checked it mathematically, otherwise I wouldn't have seen my mistake. This is why it's good to check our work, isn't it? Okay, number line G is labeled from 0 to 6. Oh, wait, but hang on, be careful. The 0's on this side. Now, usually we have the 0 on the left, but they are trying to see if we're paying attention. Okay, so there's our origin. 0 to 6, number the line, use the number line G below to answer your questions. Okay, before we get going, I want to make sure that you understand if this is 0 and this is 1, and it's cut into 1, 2, 3, 4 chunks, that means each of those is 1/4, right? 1/4, and then this would be 2/4, and 3/4, and then we get to 1, which is 4/4, okay? So each of those little lines, each of these little intervals represents 1/4, just so you know. Okay, so plot point A at 3/4. I'm going to change colors. Point A at 3/4, okay. A, easy. Plot a point that lies 4 1/2 at 4 1/2 as B. Okay, so 4 1/2, so 1, 2, 3, 4, and then 1/4, 2/4. That's our 4 1/2 right there. Is B. And we're counting from the right to the left, but that's because our origin is over here. All right, label a point C whose distance from 0 is 5 more than A. So if A is at 3/4, we want more than A, so that would be plus 5, which equal 5 and 3/4, okay? So that would be 5 and 1/4, 2/4, 3/4. Okay. And the coordinate of C would be at 5 and 3/4. Plot a point D whose distance from 0 is 1 1/4 less than that of B. So if B is at 4 1/2, 4 1/2 minus 1 1/4, so this would be 4 2/4 minus 1 1/4, which would equal 4 minus 1 is 3, and 2/4 minus 1/4 is 1/4. Okay, so 1 and 1/4 less than that of B. Okay, so here's B. And I know, because I just did my subtraction, that it's at 3 and 1/4. Oh, look at that. I was already playing with that spot, so I'm going to erase that. 3 and 1/4 is D. But I also want to show you counting the intervals, okay? 1 and 1/4 less than that of B. So 1 and 1/4 equals 5/4, right? And that would be 1, 2, 3, 4, 5. Okay, subtracting is going this way on this number line because the 0 is over here, and adding is going this direction. All right. Next one. The distance of E, wait a minute. Oh, I forgot to write that in. The coordinate of D is at 3 and 1/4. The distance from E from 0 is 1/3 more than that of D. 1 and 3/4 more than that of D. So let's see. 1 and 3/4 equals 7/4. So I can count 7 intervals, 7 little intervals. So that would be 1, 2, 3, 4, 5, 6, 7. Okay. All right. You can leave yours on there. I'm going to erase mine just because it gets a little messy. And that would be at 5. And I can do that mathematically because I know that D is 3 1/4, right? Because we just figured that out here, plus 1 and 3/4 equals 3 and 4 is 1, and 1/4 and 3/4 is 5. Okay. What is the coordinate of the point that lies halfway between A and D? And label that point F. Halfway between A and D. Okay. Halfway between A and D. And like I said, to find the halfway point, I'm just going to go 1, and then 1, and then 2, and 2, and 3, and 3, and 4, and 4, and 5, and 5. So the halfway point is right there where that number 2 is. Okay, so I'm going to draw that there. And what am I labeling it? I'm labeling it F. Okay. So, and we can do that mathematically as well, but you don't need to. We don't need to get much more complicated than that. And that would be at 2. Okay. Not so bad. Not so bad. So here's, let's see, number 4. Mrs. Fan asked her 5th grade class to create a number line. Lennox created the number line below. Okay, so here's our origin. 0 is the origin. We're not getting into negative numbers, although the line keeps going and then it goes into negative ones. We're not doing negative numbers. Don't worry. Parks said Lennox's number line is wrong because numbers should always increase from left to right. Who is correct? Well, typically when we use grids and things like that, we start the 0 on the left because that's how we read. But there's no rule that says that we have to, okay? As long as he's labeled it correctly, Lennox's number line is correct. Now, if the numbers were wrong or jumped around or the 0 was in the middle, that wouldn't work, right? Okay, As long as it's labeled correctly and you can see where the 0 is or see where the number line goes, that's fine. Some other teachers or some other math books maybe would tell you no, but we're a little more progressive here with this Eureka math. So we're exploring lots of things. You might have to turn your head a few times, okay? But Lennox, according to Eureka math, Lennox is just fine. A pirate marked the palm tree on his treasure map and buried his treasure 30 feet away. Do you think he will be able to easily find his treasure when he returns? Why or why not? What might he do to make it easier to find? Okay. All right. So he marked his number line with a treasure map, and he marked it with a palm tree, right? And then somewhere 30 feet away is his buried treasure. Okay, I'm going to try and draw a treasure box if I can. Okay, and there's the little latch. And inside is all kinds of money. It's hidden. All right, now, will he be able to find this easily if he knows that this is at 0 and this is at 30 feet? Will he be able to find that easily? What's the thing about these number lines is we don't know what direction he's going. We just know that the origin is here and that it's 30 feet away. But remember, there are 360 degrees in a circle. So his treasure could be 30 feet in any direction. He could be digging forever. Okay? Do you think he'll be able to easily find his treasure when he returns? No, I don't. Do you? Because we don't know, which direction to go. What might he do to make it easier to find? He's going to have to point us in a direction, isn't he? Yep. He needs to indicate or to point in the right direction. Okay. All right. And this is building up because this week we're going to start adding an x-axis and a y-axis. So we're going to have a couple different plot points, okay, on our coordinate grid. That's what we're working up to today. Very good. Here's your homework. Very similar to the problem set. Be careful. Plot your points carefully. Okay? All right. There's a little story problem for you. And the exit ticket is here. Just plot some points on there and then turn it in. This shouldn't be too difficult for you. If you're really struggling with this because you just don't understand what it is they're doing, ask. Okay? Ask. All right. Have a great day. And yay, we're in Module 6.